So, hello everyone, my name is Kevin and I am here with Novedge Marketing Manager Aurora Meneghello, and we'd both like to welcome you all to our latest Novedge webinar series episode. Sorry, I almost called Aurora Novedge. Aurora, would you like to say hi to all the attendees and to the MecSoft team as well?
Hi everybody, and hi Kevin. So our webinar series is becoming a weekly appointment officially next month, but really we've been running this weekly now for a couple of weeks already. So
Cool.
It's great to be back this week.
Yeah, Memorial Day weekend was absolutely awesome, but I don't want to talk much about that. Let's focus on Alibre CAM 3. Today we have the MecSoft team with us. We have with us Anita Anand, VP of Sales, and also Marketing Coordinator Tim Streifler, along with Uday, who will be presenting, and Scott Dixon as well. If you guys would like to say hi, please do so.
Hello, everyone.
Hello, everyone.
Welcome.
Hi, how's it going?
Hello, everybody.
Awesome. It's really awesome, and we're honored to have the MecSoft team with us yesterday practicing and going in depth and to help us create this presentation today. So before we get started, MecSoft Technical Support Manager Uday is part of the MecSoft Corporation. He started as an application engineer and has been with the company since 2005. In addition, he is responsible for providing technical support and training for end users. Uday holds a Master's of Science degree in Industrial Engineering from Arizona State University, majoring in CAD and CAM. Scott Dixon is MecSoft's International Sales Manager for MecSoft Corporation. Before joining MecSoft in 2011, Scott worked for Simmons PLM and has several decades of experience in the machining industry. Scott has a very strong technical background as well as outstanding people skills, which makes him perfect for managing MecSoft's international resellers and partners. Wink, wink. So, as was mentioned before, Anita Anand is the VP of Sales at MecSoft, and she is here to answer questions as well with Marketing Coordinator Tim Streifler. So, before I get started with today's presentation about Alibre CAM 3, let's talk about what we do here at Novedge. Now, the Novedge webinar series is brought to you by Novedge.com. As one of the largest online design software stores, we offer a huge assortment of software solutions that cater to virtually every designer's need. If you're interested in purchasing a copy of Alibre CAM 3 Professional, it is available in the United States and Canada from us at Novedge with zero sales tax as a download. To learn more about MecSoft Corporation's integrated CAD-CAM solution for geomagic design, also known as Alibre Design, and to get a quote from us, I encourage you to call and speak with our sales specialist, Bob Dare. You can reach him by his email address at bob@novedge.com. All right, I think you have some things you want to talk about as well.
Yes, I want to invite everybody to join our Facebook page, the Novedge Facebook page. We show a lot of images and content about architecture, 3D printing, engineering, and all the software you can find in Novedge. So join us at facebook.com/Novedge. And also next week's webinar will show an overview of VisualArc's main features and capabilities. We'll see how VisualArc streamlines workflow and improves architectural design process efficiency within Rhino. We'll also learn how to model using 3D parametric architectural objects, editable and customizable anytime, and how to create floor plans, section, and elevations drawings from any 3D model automatically. And last but not least, we will see how VisualArc adds BIM features to Rhino. So as always, this webinar will be free and it will include a Q&A session. You can get all the information on our webinar page at our website.
Cool, thank you, Aurora. And I just want a quick reminder, if you guys missed something or if you guys have to leave, this webinar is recorded live, so if you want to catch it all, catch up on the latest and rewatch this, you can head to our vimeo.com/Novedge channel and also our youtube.com/Novedge channel. Now, I want to remind everybody that feel free to submit your questions at any time during the presentation. We're going to answer them live together with Scott, Tim, Anita, and Uday behind the scenes and at the Q&A session after the presentation. So just a quick reminder there. But let's see, Uday, are you ready? Scott, Uday?
Yes, I am.
Cool. Cool. All right, I will switch presenters to Uday right about now.
I'm ready.
Cool. Awesome. Let's do this. Uday, you should be the presenter right about now. All right, enjoy, guys. Feel free to submit your questions at any time.
There we go. All right. Let me just take a minute. This is Scott Dixon. I just want to take a minute and make a few points of what you will see concerning the Alibre CAM demonstration today. I want to thank Kevin for the introductions. Let me point out what's on the first slide. Why don't you go to the second slide? Let's go with the bullet points there, if you would, Uday. Has anybody seen the second slide yet? There we go.
Yeah.
All right. If I may, the first thing I want to say that Alibre CAM is MecSoft's CAM programming system that's completely integrated into Alibre Design. This past April, when Alibre Design was taken into the Geomagic family of products and renamed Geomagic Design, we tested and certified that Alibre CAM fully runs under Geomagic Design 2013. And our plans are to release Alibre CAM later this year, and at that time, we will then make the name change to Geomagic CAM. Alibre CAM has 3 levels of functionality, which cover 2.5 axis through 4 axis continuous contouring and 5 axis index positioning as well. All right, let's go to the next slide, if you would, Uday. All right, for the presentation, Kevin has already made the introduction for Uday. His qualifications are shown on this slide. As you are seeing or watching this demonstration, if you would please notice the fully integrated nature of Alibre CAM. Uday will use the interaction from the Alibre system to select objects for machining, the regions and so forth. And he's going to show you a variety of the operations that Alibre CAM offers, from 2-axis up through 4, and as I mentioned, 5-axis indexed machining as well. So I think with that, let's just turn the time directly over to Uday and have him spend some time giving us a demonstration of the product. Thanks.
Scott, thank you for the introduction. Thank you, Kevin. And we should now be ready to get started with a demonstration for Geomagic Alibre CAM for Geomagic Design. I'm going to go ahead and fire up Geomagic Design here. Folks, are you able to see the Geomagic Design application running on my desktop?
Yeah, I can see the
Alibre CAM
yeah, there you go.
3.
Thanks, Uday. To go. Sorry.
Okay, great. Well, folks, Alibre CAM 3 is fully integrated into Geomagic Design 2013 and also certified to run in Geomagic Design 2013 and Alibre Design 2012. Alibre CAM is available in both 32 and 64-bit platforms. As Scott pointed out earlier today, Alibre CAM is available to you in 3 different configurations. We have Alibre CAM Standard, which includes 2- and 3-axis milling capabilities. We have Alibre CAM Expert, which adds the 4th-axis functionalities to it, and Alibre CAM Pro also includes indexed 5-axis milling. I just have a part loaded in here in Geomagic Design 2013. This part showcases the prismatic nature of geometries where parts like these can be programmed with ease using 2 or 2.5 axis milling techniques. Since there aren't any sculpted bottoms or negative drafts on these features, we could easily program these using 2.5D milling methods. Now once the part is loaded in Alibre Design or Geomagic Design, we would like to go to the Add-ons tab located on the ribbon bar we will now select the Alibre CAM 3 under the drop-down menu and click on Machining Operations Browser. Selecting the Machining Operations Browser automatically loads the Alibre CAM's interface in Geomagic Design. Now you can switch between your Design Explorer and Alibre CAM by toggling the button or the tab located at the bottom of your screen right there. So I can go between the Design Explorer and Alibre CAM by just one click of a button. The Alibre CAM includes two browser windows: the Machining Operations Browser that you see at the top half of your screen, and then down at the bottom you have the Machining Objects Browser. The Machining Objects Browser allows you to manage your cutting tools. You can define different types of tools. We support ball and mills, flatten mills, corner radius tools, tools for engraving, chamfer, taper, thread milling, face milling, dovetail cutters, fillet mill or corner rounding tools, lollipop cutters. You can also define user-defined or form tools, and in addition to drilling, center drill, reamer, tap, bore, and reverse bore. Now we can either load your existing tool libraries into Alibre CAM, or you can create the tools as you program the part. You can define the properties for each tool as you create them by specifying the tool length, shoulder length, flute length, tool diameter, and also from the Feeds and Speeds tab, you can specify the feeds and speeds based on the tool. You can also use the feature called Load from File to have Alibre CAM provide you with recommended feeds and speeds based on the stock material type and the tool material type that you're working with, and these feeds and speeds can be used to program the part. The Machining Operations Browser has two main tabs. You have the Program and then the Simulate tab. The Program tab includes three groups. We have the Machine Setup, the Stock, and then the Machining Operations. Now under the Machine Setup, the first step is typically to define the orientation for machining. This is the way you would be basically orienting the part and fixturing it on your machine tool in order to program this part. In this particular part, the machine tool coordinate system is oriented to the world coordinate system in Alibre. You can see that the Z-axis is normal to this face. We will now go to the Machine Tool Definition tab to define the number of axes for milling. For 2 and 3 axis application, we'll set the number of axes at 3. For 4 axis, you can select the number of axes as 4, and then you can specify your rotational axis. For this example, we'll select the number of axes as 3. In the next step, we would like to go ahead and select the post processor to output the posted file to the machine. Alibre CAM includes a list of over 225 plus different post processors, which covers a wide range of CNC machines that are out there. Now for this example, we would like to use the post processor Haas machine tool, and I'm going to select the posted output file as .nc. If the output file extension is not available on the list here, you can always click on Add New and add a new file extension to it. I'll leave the file extension as .nc and accept it. In the next step, we would like to define the workpiece or the stock material to program this part. So I'm going to select Stock and choose Box Stock. Alibre CAM automatically analyzes the extents of the part that you designed and gives you a recommendation on the minimum stock size that would be required to program this part. You change the stock dimensions, and as you change the stock length and the width, you'll automatically notice that the stock dimensions are being updated on the screen. I'll use a stock length of 5.5 inches and the width of 4.5 inches for this demonstration here today. Once the stock geometry is defined, I can click on Stock Visibility to view the stock in the Alibre Design's viewport. I can switch to the Simulate tab and load the stock simulation window to run the material removal simulation. You can also toggle the material texture based on the material type which you selected to program this part in Alibre CAM. I'm now going to go back and switch to the Program tab. I would like to align the stock to the part. I'm going to use the Align Part and Stock feature in Alibre CAM and have the stock aligned to the center of the part in Alibre. In the next step, we would like to set the material. Since I set the tool as aluminum, the tool material, it automatically assigns the material for the stock also as aluminum in here, and our cutting tool is set to a high-speed steel. Selecting the material texture automatically displays the texture being applied to the stock geometry. The next step is to establish the program 0 or the work 0 to program this part. So I'm going to click the work 0 button in here under the machining operations, and I'm going to use one of these options in here to specify the origin of the program 0. I can either use the pick option and go snap to a point or an edge in Alibre, or I can simply select to establish the origin to the stock box. I can choose the highest Z, which would be the top face of the stock blank. And for this example, I would like to use the southwest corner, which would be the lower left corner of the stock blank. I'm going to select Generate to accept it. If I would like to establish this as my work offset, G54, I can select it to output my work offset and specify the work offset register number in here as G54 or G55, and then generate it, and this information would appear in the posted code. We are now ready to generate some tool paths. So I'm going to go select 2-axis milling, and we have different types of methods that are available in Alibre CAM. We have facing, pocketing, profiling, V-carve roughing and finishing, engraving, chamfering, hole pocketing, thread milling, P-slot machining, and remachining. First, I would like to go ahead and pocket these features in here, so I'm going to select pocketing. This automatically displays the pocket operation dialog, which allows me to select the machining features. So I would like to now select the drive regions for machining. So I'm going to use select drive containment regions, and I can either select a face edge from the part in Alibre, or I could even select a sketch. So I'm going to use the advanced selector from Alibre or Geomagic Design and select the sketch number 2, which automatically selects the pocket features on this model. I'm going to accept my selection. So the selected feature automatically appears under drive regions. We will now specify a tool. I already have a 3/8 inch end mill defined in here. I can modify the tool properties by selecting Edit, Select Tool, and I can change the parameters for it. When I go to Feeds and Speeds, I can load the feeds and speeds based on the tool, or I can use the Load from File option to have it load the feeds and speeds based on the stock material, the tool material. In Alibre CAM, gives you a recommendation on the feeds and speeds. In the next step, we would like to specify the clearance plane. This is the safety plane, which is used for all transfer motions or non-cutting motions. This can be set to automatic, or you can change this to one of these values in here where you can say you want to clear the stock max by a certain height. So I'm going to leave the clearance as automatic in here. In the next step, I would like to specify the cutting parameters. I can set my tolerance. The stock to leave is any stock allowance or side stock. I'm going to leave 25,000 stock in here. I can choose my cut pattern, my cutting direction, step over distance. Now under the cut levels tab, I'm going to specify the total cut depth and the location of cut geometry. Now the features we selected are at the top of the pocket geometry here, so I'm going to leave it as at top. And for the total depth, I'm going to use this analysis tool from Alibre CAM and select the top face and then the floor of the pocket. So Alibre CAM automatically identifies the depth as 1/4 inch. I can now split this depth into multiple levels. I'm going to set the rough depth cut as 1/8 inch, so we're going to machine it in 2 levels. I can choose my ordering as depth first or level first. And from the entry and exit tab, I would like to specify the approach and engage motion. So I would like to use a helical entry and specify the parameters for the helix radius and the height. I can apply these entry and exit for each cut level, and selecting Generate creates the toolpath. The machining operation is now created, and selecting Toolpath Visibility displays the toolpath right in Geomagic Design. You can view the toolpath You can also look at the toolpath in levels by selecting the Z-level display of the toolpath. We would now like to run the verification of cuts, so I'm going to click on the Simulate tab, select the Alibre CAM stock simulation window. I will now select the pocket operation in here and click play to run the material removal simulation. You can slow down the simulation. You can also pause it and select Simulate to End to run through the simulation. You can also toggle the display of the toolpath visibility during simulation. And of course, you can rotate the stock model while it's simulating. I'm now going to go back and switch back to the Program tab to go back and program the features for the whole in here. So to do this, I'm going to make a copy of the existing operation. So select the pocket operation, do a right mouse button, click on it, and left click on copy, and paste it. I'm now going to modify this operation by double-clicking on the operation folder. I'll remove the existing features, select the whole feature on the inside of the pocket. I'll accept my selections, and I just need to verify the depth in here, so I'm going to pick the depth from the model, pick the top floor, and then the edge of the pocket at the bottom of the pocket, and then click on Generate to generate the toolpath. So we now have a toolpath generated for the whole feature on the part. We can run the simulation by switching over to the Simulate tab, select the operation, and click Simulate to run the verification. Now to go ahead and finish these features, I would like to run a profile operation in here, so I'm going to go to 2-axis and select Profiling. Again, we'd like to select the machining features. I'm going to go grab the Sketch feature in here using the Advanced selector in Geomagic Design. Select the Sketch, specify a tool for it. From the cutting parameters, I would like to choose my cut direction. And Alibre CAM has a very nice feature which allows you to automatically determine the direction of the cut for a profile based on the 3D model. So depending on the features that you've chosen for machining, it automatically figures out if the cuts needs to go on the inside or the outside on a profile operation. So I'm going to choose this option that says Determine using 3D model. For the cut levels, I'll pick the depth from the model. And I'm going to click on Entry and Exit and specify 2D entry and exit. Apply these for each cut level and select Generate to generate the toolpaths. So we now have toolpaths to finish those pockets where we left 25,000 stock from the previous pocket operation. So I'm going to repeat the same step by creating a copy of the operation to go profile on the outside of the part. So I made a copy of it. I'll double click to edit the operation. And I'd like to now go select the features on the outside edge of the part. I'm going to use the Advanced selector to grab a sketch and just modify the total depth. So the total depth is set to 1/2 inch. I would like to specify entry and exit, and selecting Generate automatically programs the toolpath for the outside. We would now like to go ahead and run the verification for the last two operations. So we'll select the profiling and click on Simulate, and that runs the verification. And we'd like to go ahead and simulate the outside cuts. Now let us consider a situation where there is going to be a design change in the model. So we would like to make some changes to the whole feature and see how we can update the toolpaths in Alibre CAM. So I'm going to go ahead and modify this feature in here in Alibre. I'm going to resize the whole feature on the model. And I'm going to go ahead and accept the change and generate it to the last feature. Now, as you notice here, since the features were modified, Alibre CAM automatically flags the machining operations as dirty, indicating that you made some change to your design feature. So you can simply select the operation folder, right mouse button click on it, and select Regenerate, and in this process it'll automatically update the toolpaths. So if you need to reselect the machining features, you can just go back in here, double click to modify, and just select the machining feature and generate your toolpaths. So that's how simple it is. When you edit the feature, you can go back and regenerate your toolpaths. Now I would like to take a look at the total estimated machining time for this process. I'm going to select the setup folder number 1, right mouse button click, and select Information. And based on the parameters, the feet and speeds that we specified, Alibre CAM gives you an estimated machining time for each operation. We'd now like to generate a setup information sheet, so I'm going to select the shop documentation feature in Alibre CAM, and this creates a nice little report which provides you with details of the tools being used, lists all the machining operations that you programmed, and gives you a nice little picture or a screenshot of the part that's being programmed in here. So there's your shop documentation. It lists all the different operations in here. We have the 2 pocket operations and the 2 profile operations. Specifies the tool that's currently being used and also the total machining operations and the time involved for machining this part. Now, the last step I'm going to do here is to post-process these out to the machine. So I'm going to select the operation in here, right-click, and selecting Post will post-process all the operations in the sequence in which you have it programmed. I'm going to specify the file name and select Post, and this automatically post-process the file and displays it in your text editor or the NC editor you've chosen. And here's the posted code, and this program is now ready to be sent out to your CNC mill. Now, one of the nice features I like in Alibre CAM is ability to save these operations out to a knowledge base. So I'm going to use this feature called Save to Knowledge Base and specify a name for it. Alibre CAM automatically archives all the machining operations with the parameters, the tool, the feet and speeds that you specified into a knowledge base. So when you're programming family of parts, rather than having to go through the process of recreating each of these operations, you can actually go ahead and load the knowledge base of machining operations into the part and just associate the machining regions to the operation and generate your toolpaths. Now, this kind of gives you an overview of the 2-axis machining methods that are available to you in Alibre CAM. We would like to now take a look at a 3-axis example and see how we can program a part in 3-axis. So I'm going to go ahead and load a part in Alibre, which includes some sculpted surfaces, some drafts, fillets that are built into the model. The part is currently being loaded in Alibre or Geomagic Design. Is everybody able to view the part?
Yes.
I see it.
Yeah, I see it.
Okay, thank you.
Oh, I'd
So
also like to,
Uday,
I'd like to recommend
Thank you, Kevin.
the refresh rate for the screen is a little bit slow. If we could compensate for that and I guess take it a little slower so the refresh rate can catch up or something.
Sure, I'll definitely do that. Thanks, Kevin.
No worries.
So I'm going to go ahead and click on the Add-ons tab. And like we programmed the 2.5-axis example in here, so I'm going to select the Alibre CAM and click on the Machining Operations browser. So the Machining Operations browser automatically loads in Geomagic Design or Alibre Design, and you'll now be able to see the Program tab, the Simulate tab under the Machining Operations browser, and the Tools, the Machining Regions, and the Knowledge Bases tab in the Machining Objects browser. Now, to program this part, since there's sculpted surfaces on the model, there's fillets, there's drafts, we can program features like these using Alibre CAM's 3-axis machining methods. The workflow is very similar to what we did on 2.5D milling. In the first step, we'll make sure the machine tool coordinate system is defined, so we'll make sure that the orientation, the tool, the z-axis is normal to the face we're trying to mill, and then under the machine tool definition, we'll make sure the number of axes is set to 3 axes. In the next step, we would like to go ahead and select the post processor. So I'm going to click on the post button in here, and from the list of post processors, I'm going to go ahead and select the post, and I'm going to use Haas as the machine tool in here. I'll click OK to accept it. And now I'm going to define my stock geometry. I'll click on stock and box stock. And in this process, I'm going to define a stock, which is the stock thickness slightly larger than the thickness of the part. So I'm going to add a slight thickness to it and modify this to 1 1/4 thick material. Now in the next step, I would like to align the stock to the part, so I'm going to use the Align Stock feature in Alibre CAM. Align the stock, have the stock flush to the bottom of the part, and have it centered in X and Y. We are now ready to program the machining operations. We can select from the variety of different 3-axis machining methods that are available to us in Alibre CAM. So I'm going to go ahead and start with the roughing process. So I'm going to use 3-axis roughing. Now before I generate my roughing process, I would like to go ahead and establish my work 0 or the program 0 for machining this part. So I'm going to go select on work 0. I'm going to set the origin to the stock box. I'll choose highest Z for the 0 face, which would be the top face of the stock. I'll choose the southwest corner, which would be the lower left corner for the program 0 or the work 0. And I'm going to select generate to establish this. Now typically when you're starting out with a raw stock, you would probably want to rough it down as far as possible to bring it down to the finished shape of the parts. I'm going to start the roughing processing here by selecting horizontal roughing. Now the horizontal roughing, parallel finishing, horizontal finishing, all of these machining methods are available to you in standard, expert, and pro configurations of Alibre CAM. So for the machining features, I'm going to skip the process of selecting a drive or a containment region. So Alibre CAM automatically analyzes the entire 3D model and computes a tool path based on the stock and the part geometry. Now the drive or containment regions are selected in Alibre CAM for 3-axis machining methods to contain or limit tool paths to specific areas. You can either select a face edge or a sketch to contain your tool paths. We would like to select a tool in here, so I'm going to grab the 1/2 inch end mill for the roughing process. I'm going to leave the feet and speeds to be loaded from the tool. For the clearance definition, I'm going to use automatic for the clearance plane. And now under the cutting parameters, I'm going to specify my tolerances for roughing. I'm going to set the tolerance as 2000 and leave 25,000 stock. So it's going to leave uniform stock in all 3 axes, so we can go back and then create a finish or a pre-finish operation. I can set my cut pattern, cutting direction, my step over in here for the roughing process, and also I can control the step down parameters for the roughing process. I'm going to go ahead and select generate, and Alibre CAM automatically analyzes the part and the stock geometry and creates the roughing toolpath in here. So it's in the process of computing the roughing toolpath, and in just a moment you should be able to view the toolpaths generated on the part. So I can click on the toolpath visibility and select the toolpath display in levels to view the toolpath as we step through each Z level. We would now like to run the verification of cuts. I'm going to go switch over to the Simulate tab in here, select the simulation window, click on the roughing operation, and select play to run the material removal simulation. During this process, I can rotate the stock model. I can also pause the simulation and click on Simulate to End to run through the simulation process. So this completes the roughing process in here. We would now like to go ahead and program finishing toolpaths. So I'm going to go and switch over to the Program tab, and I would like to load some knowledge base of machining operations that are already pre-programmed. So I'm going to go to the Knowledge Bases tab under the Machining Objects browser. I would now like to select Load Knowledge Base. I'm going to grab this knowledge base for 3-axis, and this automatically loads a few machining operations in here. So I'm going to grab this parallel finishing operation from the knowledge base and drag this and drop it into the machining operations browser. So this knowledge base was programmed on a different part, so I would like to use the same set of parameters. I can modify these parameters by double-clicking on the operation folder to take a look at the tool that's being used for the finishing operation. I can modify the feet and speeds if required, specify the cutting parameters, and then selecting Generate computes the toolpath. Now we are generating a parallel finishing toolpath in here, which generates a finishing cut, and the toolpath follows the 3D model. So you can view the toolpath right on the model here. So that's your 3D finishing toolpath, parallel finishing. We would now like to run the verification of cuts in here. So I'm going to go switch over to the Simulate tab, select the parallel finishing operation, launch the stock simulation window, and then click play to run the simulation. This shows the material removal simulation of the cut material verification for the parallel finishing operation. To run through the simulation, I would select pause and simulate to end. Now, one of the advanced toolpath methods that are available to you in Alibre CAM Pro is a method called pencil tracing. So I would like to show you or demonstrate the pencil tracing toolpath in here. So I'm going to select pencil tracing. So Alibre CAM automatically analyzes the model, identifies all the bitangencies on the part, and creates a toolpath to create a cleanup pass. So this would save you time in creating refinishing or remachining the part. So I'm going to use the 1/8" ball mill in here, specify the parameters, and Alibre CAM automatically identifies the bitangencies on the part to generate the toolpath for the pencil tracing operation. The pencil tracing is one of the advanced 3D toolpath methods which is available to you in the Pro configuration of Alibre CAM. We would now like to go ahead and run the verification of cuts. I'm going to click on the simulation window, select the pencil tracing operation, and click on play to run the simulation. You'll notice that it generates a cleanup pass around the model. Now, once the toolpaths are programmed, we could take a look at the estimated machining time. So right mouse button click and information. You see the total machining time. Right click on the setup folder and selecting post will post process the toolpaths out to your machine. And here is the posted code. Now, the Pro configuration of Alibre CAM also offers some advanced toolpath editing methods where we have a feature called Toolpath Editor. We can go ahead and load the Toolpath Editor by just double-clicking on the toolpath object under the parallel finishing operation, and now we can either instance these toolpaths. We can also fit arcs to toolpaths, so arcs can be fit in all the 3 principal planes, which could be X, Y, XZ, and YZ planes. So we can specify an arc fit tolerance, and these would fit arcs to your toolpath. So you can see arcs being fitted to the toolpaths in the 3 principal planes of the model. So this basically reduces the lines of code and results in a much smoother cut. The Toolpath Editor is also one of the advanced features which is available to you in the Pro configuration of Alibre CAM. I would now like to demonstrate a 4-axis example where we can take a look at milling parts on a rotary table using 4-axis methods. So I'm going to go locate a part in here. The part we are trying to program is a gear which we'd like to program on a rotary axis. The part is now being loaded in Alibre Design or Geomagic Design. The workflow is very similar to how we program parts in 2.5 and 3 axis. I'm going to load the Alibre CAM browser from the Add-ons tab. We would now like to go ahead and define the machining process in here. First step is to establish the machine tool definition. So we're going to click on the machine tool setup and click on the machine tool definition tab, and we would now like to set the number of axes as 4 axes. Now, based on the configuration, typically in most cases it would be a rotary table or it could also be a rotary head. So we're going to select the machine configuration as a table, and once you select the machine configuration as a table and the number of axes is 4, you can then specify your rotational axis, whether the rotary axis is going to be about X or oriented about the Y-axis. Now this can be defined, and you'll notice that the axis indicator is represented by an arrow right in the viewport in Alibre Design or Geomagic Design. Once we establish the rotational axis, we can then define our stock geometry here. In this particular case, I'm going to define the stock as a cylinder stock. I can specify the stock radius and also the stock length, and as I modify the radius, the stock dimensions are automatically being updated in Alibre Design or Geomagic Design. Now we would like to program this part in a couple of different ways. One of the methods you can do is you can rough it using an indexed method where you program a 3-axis operation and then you program what is called a rotate table where you can have the rotary table rotated by a specified rotation angle. So in this particular demonstration, I would like to show you how to create a toolpath using rough it using indexed machining process. So we're going to create a roughing operation in here using 3-axis roughing process. Now in order to run the simulation, I'm going to switch the simulation model here from voxel to polygonal, so which can also simulate undercut features during simulation. So I'm going to go select the stock simulation window in Alibre CAM, select the roughing operation, and click play to run the simulation. So I can also select the pause and click simulate to end to run through the roughing process. Now we now have the simulation performed for roughing the top half of the part. We would now like to introduce a rotate table setup, and you'll notice that the Z-axis is oriented towards the bottom of the part. So on your machine, the part is oriented or rotated by 180 degrees or whatever the rotary angle that you specified, and now we'll program a roughing operation from the other side. I'm running a simulation of the roughing toolpath for the bottom half of the part. I'm going to click the pause button in here and select simulate to end to run through the simulation. Now once we are through with the simulation programming of the top half, I can rotate the rotary axis back to 0 and program a continuous 4-axis finishing toolpath. So we are programming a 4-axis parallel finishing in here, where you can specify your cutting parameters. You can choose your cut pattern as either across or along axes. You can specify your axial containment, specifying the low and the high values, and also you can do multiple levels by specifying step downs in here. So we would now like to run the simulation. So select the simulation window, select an operation to simulate, and click play to run the simulation. This shows the simulation of the 4-axis continuous toolpath in the Alibre CAM. I can select pause and click simulate to end, which basically runs through the simulation. The part is now simulated. We can go back and take a look at the estimated machining time. Right-click on the machining job and selecting information will list the machining time for each and every operation. Now there are several other 4-axis methods that are available to you in Alibre CAM. You can program facing, pocketing, and profiling. We have 4-axis R-level finishing, parallel finishing, projection pocketing, and engraving in 4-axis. Now we would like to post-process these operations out to the machine. I'm just going to go ahead and post the last operation, which would be the parallel finishing in here. Right-click and select Post. We'll post-process these toolpaths, and the posted code shows your rotational axis in addition to your X and Z axis motions. Now finally, I would like to demonstrate how to program parts in Alibre CAM using index 5-axis, also known as 3+2 machining. So I'm going to load this part, which has features that needs to be programmed or machined from different sides. So there are features that needs to be milled from the top, from the front, right, and back. So once the part is loaded in Geomagic Design, I would like to load the Alibre CAM browser, and I'm going to define my machine tool definition by going over to the machine setup dialog in here. So I'm going to click on machine setup. I'm going to set the machine tool definition, set the number of axes as 5 axes, and in the 5 axes we have 3 different configurations we support. We have a head-head configuration where the 2 rotational axes are on the spindle, or it could be a combination of the rotary table and a head, or it could be a table-table configuration, which would be like a trunnion style machine. And once you select the configuration, you can choose the rotary axis for the primary and then the secondary axis. Here we have features that needs to be programmed from different sides. So we would basically define what is called a setup, where we orient the tool axis to a specific orientation or a plane. So we lock the tool axis to a certain orientation. We can specify the orientation either by selecting a face or a surface in Geomagic or Alibre Design. I can click on Select Surface, I can pick a face, and this automatically orients the tool axis based on the surface normals. Now once you establish the orientation, you can program a combination of 2 and 3-axis operations in here. So we programmed a couple of different operations. We have a facing operation, we have roughing, finishing, and drilling operations that is programmed for the top face. In the next step, we would like to orient the coordinate system to the front face by defining a new setup and selecting the orientation by specifying a face, and automatically the tool axis is oriented to the face that you chose, or you can orient by specifying the spin angle and choose the coordinate you want to orient it about. Again, we are programming a couple of different operations. We have facing, pocketing, and profiling for the front face. Likewise, you can repeat it for the right side and the back face. Now we would like to go ahead and run the verification of these operations by simulating them. So I'm going to go switch over to the Simulate tab, select the simulation window, and I'm going to select these operations in here, all 4 setups, and selecting Play runs the material removal or the cut material verification in Alibre CAM. So it's simulating the facing operation for the top face. It then progresses over to the roughing toolpath for the top face and the part. I'm going to run through the simulation in here. I can also toggle the display of the toolpath while it's simulating. You can also control your simulation speed and the accuracy of your simulation by modifying the properties in the simulation window. So that shows the simulation of the front face, the right face, and then the back face. This concludes the demonstration of Alibre CAM's capabilities, the ease of use, and the power of Alibre CAM just fully integrated into Geomagic Design. Back to you, Kevin.
Hey Uday, thank you. Thank you for that demonstration. I just want to give you a heads up. We have a lot of questions, so let's get started. I think Anita, Tim, and Scott are really busy answering questions in the background. So for the attendees, just a reminder, if we don't answer all of them, what we'll try to do is submit and format these questions in a PDF and post them as a blog, which MecSoft will work together and then answer them, and we'll share this on our blog post at blog.novedge.com. But let's get started at the top. Uday, let's see. Okay. Let's see. There's a lot of questions. Give me a second here. Okay, will Alibre CAM will Alibre CAM support ultra high performance toolpath or dynamic milling?
We currently have some options for high speed machining. Like for example, we can perform smooth connections, or we can perform corner rounding, but we currently do not have an exclusive high-speed machining module. That's something our engineering team is working on, and hopefully we should have something by the next release. But we do have some features that will help in some of the high-speed machining features.
Cool. Also want to try something new here. So everybody on the MecSoft team, if you like, just unmute yourself. So if it's a question that you answered, I think it would be best if you want to answer that too as well. But thank you, Robert, for that question. Let's see. So this is kind of a marketing one. Does Alibre CAM have to be purchased at the same level of Alibre CAD that we have? Uday? Or?
Yeah. I saw that was answered. No, it does not. You can purchase different levels of the Geomagic Design system, and completely independently you can purchase the Alibre CAM levels that you need for your machining capability. So it's not dependent at all on the CAD or the CAM. There's just no correlation there. You can choose on whichever level for CAD and whichever level for CAM is appropriate for your needs.
Cool. Also, John wants to know, is the collisions in red only in Alibre CAM 3?
Uday, do you want to answer that?
Yeah, sure. Kevin, would you mind repeating the question?
No worries. John wants to know, are the collisions in red only in Alibre CAM 3?
We do have a tool holder collision detection, which is available in Alibre CAM 3 Expert and Pro configurations. So if there is a collision of the tool holder with the stock material, then those areas are marked in red during simulation.
Okay, cool.
And that was not available in the Alibre CAM 2, correct?
Gotcha.
I believe we probably may have had it, but I'm not 100% sure. I would have to check on that and get back to John on about it.
Cool. Okay, so Leo wants to know, is there a way to simulate the holding fixture or set it up to provide clamp/hold down avoidance?
You would actually have to model these in your part itself, so you can use it with the simulation, but we do not model or display the fixtures during simulation.
Cool. Okay. Michael wants to know, how about 5-axis simultaneously? I'm guessing that's a question of whether or not it's possible.
Alibre CAM professional configuration. I'm sorry. Go ahead, Kevin.
I'm guessing that's a question of whether or not it's capable right now to have a 5-axis simultaneously.
Currently, it's only capable of indexed 5-axis programming, Alibre CAM 3 Professional. Our standalone configurations, which is available in premium configuration, which supports simultaneous 5-axis. So that's something our engineering team is looking towards for simultaneous 5-axis. Anita, would you like to add a word about it?
Sure. If there is currently, like Uday mentioned, it is available in our standalone visual mill product. Yes, that doesn't work integrated with the Alibre Design or Geomagic Design products, but we will be definitely looking at adding it as a fourth configuration, a premium configuration, if there's enough requests from our Alibre Design customers. Certainly, yes.
Awesome. Okay, so that leads to the other question. This one is about, let's see. This is from Robert, and he wants to know, I'm already using the 5-axis indexed CAM versions, but I'm missing tutorials for 5-axis. Will you implement more info regarding 5-axis?
Yes, most certainly. This is something, a project that's ongoing in MecSoft. So we definitely are aiming towards adding more and more tutorials, especially in the 4th and 5th axis feature lists. So yes, do bear with us. We are working really hard to get more and more help for our customers.
Okay, so both of these questions are kind of about like a way to communicate with you guys. Do you guys have like maybe a forum where I guess the attendees, customers, users can interact with you guys and to communicate, to learn more about the product and to communicate certain issues?
Yes, we do have an open forum which is available to all our customers through our website. If you want to go to MecSoft.com and go to our support tab, there is a forum that can be accessed to all our customers. Now, there is also a premium forum that is available for our maintenance customers. This gives you a little more information and help with the product, so it's a little more of a higher level forum that is available for the maintenance group of customers. But yes, there is a lot of help out there, and we are always here available, just a phone call away.
Cool. Okay, so let's have 2 more questions here, and let's see. All right, is there any integration of features like drill pecking or tool change pausing without having to manually edit the output file?
Uday, do you want to answer that one?
Sure. For machining of holes, I don't know if you're looking at this part here, so you can actually select features directly from the part by select holes on a flat area, and you can pick the face where all the holes are located, and Alibre CAM will automatically identify all of these holes. And if you have holes of different sizes, you can use the diameter filter in here to filter them out based on a certain size to select these holes. Now, if you want to answer the second half of the question, if you want to pause or stop between two operations, we actually have a very nice feature in Alibre CAM called a machine control cycle. So you can go under create miscellaneous operations, and you can create what is called a machine control cycle in here. And this cycle can be used to output a specific set of information, and it could be like a pause command, or you can have an optional stop programmed, and this information can be added into your post processor, so you don't have to edit the posted code. You can actually add this information into your post processor, and then when you post process these operations, it'll output the instructions to either pause or stop the machine between operations, or between tool changes or whatever task you want it to perform.
Okay. One last question. This is from John as well. Well, actually, let's do this one from Dave. Sorry, John. What about a lathe module? I'm assuming that's what Dave wrote. Do we have any?
Sorry, I didn't quite get that. Can you please?
Let me assign this question to you. Yeah, no worries. What about a lathe module?
Spell that.
It's L-A-T-H-E.
Oh, late.
Late?
Late. Late module.
Very good.
Gotcha.
Scott?
Thanks, Dave.
Yeah,
Thanks, guys.
we currently have a standalone product that is visual turn for doing lathe work, and this year we have worked very hard through development and are going to be releasing an integrated turning product, which is very much like what you see on Alibre CAM as far as its integration. And it will have enhancements, and a number of restrictions will be taken out. So we do have that product available. It's called Visual Turn.
Cool. All right. Let's see. Okay. Let's answer this last one. I promise this is going to be the last question. And I want to remind everybody that we're going to format these questions and turn them over to MecSoft, which they will then answer and we'll post on our blog at blog.novedge.com. Sorry. Okay. So John wants to know: do you have a EDM module?
Currently, we do not have an EDM module, but that's something in the plans. May not be with the next release, but as and when we get more and more requests for it, yes, that is in our plans.
And
Cool.
specifically, I'm sure this is asking about a wire EDM module. Does he specify that?
John, can you specify that? Yes.
Yes. Okay.
All right.
Cool. All right. That about sums up our Q&A session, and I will transition back to me as the presenter. So I'm going to take over control, Uday.
Sure. Thanks, Kevin.
No worries. Let's see. All right. Let me know, everyone, if you can see my slides here. Oh, not that. There we go. Do you guys see my slides? Not the control panel, right?
Yes, we do see the slides.
We see your slide, yes.
Awesome. Yeah, so, on behalf of Novedge, I want to thank the MecSoft team, Anita, Scott, Uday, and Tim for joining us today. They've been marvelous and just superb in answering all of your questions behind the scenes. And as a quick reminder, you can find these answers. We'll work with MecSoft to post these and share these answers at blog.novedge.com. Oh, there you go. That's our thank you screen right there. Now, if you're thinking about purchasing a version of Alibre CAM 3.0 Professional, the Novedge webinar series and the Novedge, you can check out our product page. You can check out our product page at novedge.com. If you're interested in picking up a copy, it is available in the United States and Canada from us at Novedge with 0 sales tax as a download. If you want to learn more about MecSoft Corporation's integrated CAD-CAM solution for geometric design, also known as Alibre Design, and to get a quote, I encourage you all to call and speak with our sales specialist, Bob There. You can reach him by his email address, bob@novedge.com. If you like what we're doing, if you want to let us know how to improve what we're doing as well, feel free to check out facebook.com/Novedge. Throw us a like here and there. This will be a good way to catch up on all the latest webinars and also to see what's going on with the industry and the design world as well. And just a heads up, we have a upcoming webinar next week for Visual Art, which is a plugin for Rhino. Learn about efficient workflow and architectural design from the Visual Art team, and this is hosted by Francesca Salah. So if you want to get more information about this webinar, head to novedge.com/webinar/74. And if you have any questions and comments, feel free to send them out over to me. I'm always looking for feedback and criticism. So just send them at kevin@novedge.com as well as bob@novedge.com. And some of you guys were wondering if this webinar is recorded. This webinar is recorded, and you guys, at today's end, you guys can check it out at vimeo.com/Novedge and youtube.com/Novedge. So on behalf of the team, thank you, MecSoft. MecSoft, Anita, Scott, Uday, I'm just trying to remember all your names. Tim, do you guys have any last words before we sign off on this webinar today?
Well, thank you for hosting our product on your webinar. We really certainly enjoyed chatting with some of our perhaps customers and leads who are interested in our product. So, and if you have questions, talk to either Bob. You're also welcome to call anyone at MecSoft. We certainly will help everyone who needs any assistance with the product. So thank you again to Kevin and Aurora for hosting this nice webinar.
Thank you, Anita. Thank you, everybody. This is great.
Cool. All right. All right. Thank you, guys. Ciao.
Thank you.
Have a good one. Follow us at Novedge. See you guys later. Bye.
See you. Thank you.